Hello, I'm Chris Athanas. I'm a KMP developer. Tech support says they're coming out Tuesday. They promised this time. I'm not holding my breath. Today I'm reacting to avoiding a big ball of mud, coupling in a monolith. So, I mean, the number one mistake that was happening, and I think it is the normal thing that happens anyway, when people learn how to do like back end development stuff, is they just take the tutorial and go right and think that's deployable to production. And what happens is, the separation of concerns between the different services gets to be all mixed up in one database, which is actually pretty okay if you're just doing it one to figure out some use case or the business scenario, and then you're gonna throw it away. Totally legit. That's fine. But if you continue to go with that initial 1.0 and try and build on top of it and keep going with it, it's like going to be like the Windsor House in California. If you don't know what that is, I think it's San Jose. If you don't know the Windsor House, go check that out. That's a big ball of mud. Here we go.
How do you avoid a monolith from becoming a big ball of mud? One aspect is coupling. While onion architecture and direction dependencies matters, in this video I'm going to focus on boundaries and how you're coupled between them. Hey everybody, it's Derek Martin from CodeOpinion.com. If you're new to my channel, I post videos on software architecture and design in .NET, so if you're into those topics, make sure to subscribe.
He does stuff on .NET, but he also does like general, like just back-end advice videos, which is why I like him, because I don't use CNET or C# or any of that stuff, but Kotlin and Java are so similar, and a lot of the ideas are very similar, and the overall concepts is what we're looking for, not the actual code samples. Go ahead.
Right. So I mentioned onion architecture and direction dependencies, and you may have seen this diagram before, is that in the center you have your domain. Outside of that you have things like domain services. On top of that you have application services, and on top of that you have things like infrastructure, UI, tests, etc. Now, while dependencies and coupling matters in this sense, this is really showing this concept of the direction of dependencies, meaning the domain has no dependencies, and then outward it has a dependency on the domain, and the application services have a dependency on the domain services, and etc. Now, while I think this is really important, it's an interesting concept, I'm going to share this for another video, because really what I think is actually even more important than this in a large system, especially in a monolith, is actually how you couple between boundaries and what those boundaries are. So when I talk about boundaries,
yeah, this is the key part. All other stuff, the circles, everything like that's okay, whatever, you're going to figure that out anyway. But this part right here is not obvious and definitely gets everyone in trouble, at least once.
And in my loosely coupled monolith project, which I'll have a link in the description, I talk about having defining boundaries. So your monolith just isn't a big ball of mud. You have well-defined boundaries. And in my particular solution, I've defined boundaries of sales, shipping, and billing. Now, these are distinct projects that have references that I'll show. But what I'm really after here with the coupling is, how are you communicating? We're doing in-process communication. So obviously sales is going to be calling some method in shipping or billing, etc. There's going to be some interactions. But how you...
And this could be inside of a single monolith, a K2R monolith. These are just different parts of the program. But they're all separate, and they only access their table in their database, or only their database, and they don't access somebody else's database's table. That's the problem. That's coupling too much. The coupling you're going to have between the services is acceptable. We can manage that one, but when you go down to the actual table and row and column, yeah.
Do those interactions and how you reduce coupling is really the key to preventing a big ball of mud. So I'm in my loosely coupled.
That causes the database direct database access with all the services, even though it's convenient while you're writing it, becomes the ball of mud.
Monolith project, and you can see how I've had these boundaries defined. I have a solution folder with for billing with a billing project in it. This is just a class library, and another class library called billing.contracts. This project is important. Same thing for sales, that exact same structure, and the same thing for shipping. Now, the way these works in terms of references and how we're going to couple between everything is that billing will not take a reference to another, what I call implementation project. It will not take a reference to sales or shipping. Rather, it will take a reference to things in the contract project. So
what does he say? I guess what he's saying there is like, you can't just go in to the database. You have to go through the service. Okay.
Usually, the way that you can think of this is that each one of these boundaries, within a boundary, you have implementation and contracts. An implementation will only ever reference.
So I guess in Kotlin, these would be called interfaces. If you're going to use the RPC stuff, which I did a video about a little while ago, this is the interface. This is the implementation. And it's just, I like the word contract better than interface, honestly. I think C#, that's a C# term. To correct me if I'm wrong in the comment below.
Contracts from another boundary. That's the way this works. You may have contracts reference other contracts, but between boundaries, you're only going to reference the contract project of another boundary. So as an example here, I'm in the...
In other words, you're only going to call methods from in the other boundary. That's it. That's all that was, is that you can only call methods. You can't directly go into the database that service is running and go to some table in some row, and no, don't do that.
The place order handler. So I'm in my sales boundary, I'm in the sales project. And what this does is this takes a dependency on an iWarehouse inventory. And it's using that interface here that gets injected to call a method called do all products have quantity on hand. Now I'm using an interface because it's less coupling than a concrete class, and because this iWarehouse inventory is going to live in, I'll go to the definition, this actually lives in the shipping contracts project. So from shipping, what we're doing is we're providing an interface, which is a contract, and we're providing that to all the other boundaries. So all the other boundaries can inject this interface, and the actual implementation of it, if I jump over here, is actually lives in shipping. So
the service is all separated, and if you want to call, you have to call into the service methods. Okay.
Place order handler, which is in sales, takes a dependency on that interface from the contracts project of another boundary, in this case shipping. And then our implementation is actually in the implementation project for that boundary, shipping. Now, last piece of the puzzle here is in configure services, I have an extension method for each different boundary to basically register all their interfaces to their actual implementation. So that's where I'm doing it here, where I'm registering the iWarehouse inventory to the warehouse inventory.
It's some implementation detail that we don't have to worry about for Kotlin, Ktor, RPC
implementation. So that's how ultimately, when we resolve this in ASP.NET or ever using our Microsoft DI, we're actually going to get the implementation from shipping behind this interface. So one thing I don't see very often are the use of delegates. And delegates can also be treated as contracts similar to interfaces. And I think oftentimes they'd be much better served than creating interfaces that have really low cohesion and just become a dumping ground for methods, for queries, or data that you want to get from another boundary or another service. So I'll use this test as an example here. And this is one kind of way that you can tell this, is that I have this place order handler. And for the iWarehouse inventory that we need, obviously I'm not going to use the real implementation because I don't want to hit the database or do whatever shipping was doing with this. So I end up creating my own fake, and I make it do what ultimately I need it to do for my particular test. But the problem here becomes if our implementation of this handler actually changes, maybe with our fake for this particular test, we've set this up in a particular way, but maybe we haven't really implemented everything yet. And then ultimately our test fails along the road because our implementation changed. Because maybe we were calling do all products have quantity, and then maybe we added some method in the future, and the implementation changed that we were no longer calling this particular method.
So it's just saying sometimes the fakes are going to are not going to be in sync with the actual implementation, and you're going to get a gotcha one at some point because they're out of sync.
So again, if you look at this iWarehouse inventory, none of these methods relate to each other at all. None. So I wouldn't suspect that a dependency on one of them, like I would expect a dependency to need to call one method, not many methods, particularly of them. And behind the scenes, these probably likely have nothing other than maybe a database connection or database context relevant to them. That's the only really cohesion they have to each other of these methods. So the one thing that you can do that I highly recommend, and is I think a far easier way of, especially with testing, is to create delegates. So what I've done here in this particular case is in contracts, I've actually created a static class, and I've created a delegate for this particular method of that interface. And what I can do then is what I'm going to do is I'm going to change this implementation to show you how this works. Is instead of injecting this interface, because all I really want, guess what, is a function, which is the delegate. So instead, I'm going to inject this delegate. We'll call that do all products have quantity on hand. We'll get rid of our warehouse. And then rather, we can just call this function, which is what we were after. Then over in our test, instead of needing to pass in this fake, or we created a mock or whatever the case may be, now, what I'm really doing is creating an implementation of that delegate to do.
Okay, so he's just making a local function for that particular method. Okay.
What I want to do specifically for this test.
This is a C# implementation. So he's just saying sometimes the testing you want to make. He's saying here that find out ways. I think you can do this in Kotlin. I'm pretty sure you can, where you can just implement implement everything as is for before, except you change one little item that you're testing. I think you can do that in Kotlin. So he's just saying make sure the tests are in sync.
And then in registration for shipping, I will go to my configure services, and I can do register that delegate by a transient, and it was in the warehouse inventory query dot quantity on hand. Get required service. And then I'm basically just registering that delegate to resolve our implementation and pointing to that particular method. So this is just a way I find that I think delegates are way underused for this purpose, and they're exactly that same thing. They're a contract. They're allowing other boundaries to either perform actions or return data, and it allows you to get a little bit more granular instead of creating essentially interfaces that become dumping grounds oftentimes for different types of queries. So finally, to go as far as we can with coupling is to go full-blown messaging, and I've talked about this a lot in my loosely coupled monolith, is exactly that, is loosely coupled via messaging. So
yeah, so to get away from all this coupling stuff, you're going to have a message broker, and You can either do it, I like the Redis. I think Redis is great. It's a great solution for doing this kind of thing. But, if it doesn't have to be on all the time, you could just use an in-memory flow queue inside KTOR if you just want to get your system up and running and you don't have any customers yet. You just, you're not worried about a heavy load. I mean, it's not a bad way of doing it. It's just all the stuff is in RAM.
Instead of our contracts communicating like I just showed in process, is moving that out of process asynchronously via a message broker.
I should say the message broker is in RAM. Everything else is being persisted in a database somewhere, of course.
So any particular one of our implementations can send a message to a message broker and then have a separate process, what I call the message processor, be connected to that message broker, receive those messages, and then basically dispatch those messages to the relevant boundary that needs to listen to it.
And this could be, this whole could be just one big KTOR server. And these databases could be just tables for these different services. And, the HTTP server is getting messages from the outside, and it passes it along to this message processor that put things in the broker or put things, or take the things from the broker and put them, give this to each service in turn asynchronously. That's the big idea. This is the way to get away from the coupling. You're eventually going to do it. So think about it ahead of time. It's the whole point.
So if it's a particular command, it will go to one particular handler in some specific boundaries implementation. If it's an event, it may get dispatched to all the different boundaries or whatever one ultimately have the consumers that need to use it. But if you want to get in more into the loosely coupled aspects of this, I'll have a link in the description for my loosely coupled monolith. The key for me really is defining boundaries and then defining the contracts within those boundaries. And then having your dependencies be from implementation to the contracts of other boundaries. Don't directly reference the implementation from another boundary. Only expose the things that you want to expose per boundary and put those in your contracts project. If you want to go even farther, loosely couple via messaging, and you're still going to do the same thing here, you're going to put your messages in the contracts projects so that you can use those messages to send a command or to consume an event.
That's just an implementation detail of how that framework works. But the ideas are the same. The ideas are sound. I wish there was a better channel for KTOR for this kind of information, but there isn't yet. So I'm trying to fill the gap in of like how we can use some of these ideas that I've seen and what got me up to speed faster. It feels like directly apply. I mean, hope you get the basic ideas. Like service boundaries are super important. That's the takeaway.